In this video, we are going to integrate over the following solid. So here we have a solid bounded above by basically an upside down cone. So 7 minus square root of x squared plus y squared. So you can see the little cone. It looks just like a circus, right? And laterally is by the cylinder x squared plus y squared equals 16. And below by the xy plane. So that's just z equals 0. Okay, so how do we set up the limits? So the first thing we need to do is set up the bottom surface and the top surface. Now they do tell you is the top surface is that cone, and in cylindrical coordinates, everybody needs to know that x squared plus y squared is r squared. So here we got 7 minus square root of r squared, which just means 7 minus r. So that's going to be your top limit. So that's going to be here. Your bottom limit, because it says on the bottom, but the xy plane is the same as z equals 0. So that's the same whether it's cylindrical or rectangular because z is the same. So here z equals 0. And then over here, these limits are going to be just like polar if you were to project this thing on the xy plane. So you can see that this is a circle, and it looks like it's radius 4. So we can actually see that the radius is 4. But how do we know that? So to actually imagine that there's no picture. So what will happen is that you would have to understand that this circle has the same radius. So if I go over here closer, and I can see that this cone intersects with that cylinder, right, at x squared plus y squared equals 16. Do you see that? So that's why the projection of this thing is just going to have radius of 4. So if the radius is 4, then the limits are going to be for r from 0 to 4. That's the middle ones. And for theta is all over from 0 to 2 pi. Okay, so now what are we going to integrate? So normally the integration, for example, if they say find the volume, then that would be just integrating 1, but multiplying it by r. And r is this extra, what they call Jacobian. And I always tell my students to remember that the pirate says r so that they don't forget that there is an extra r here. So it's always going to be there. Just kind of comes out of nowhere, but it comes out of going to a different set of coordinates. But the problem here is that we're not integrating something that's easily convertible to cylindrical. So what am I talking about? Like if you have something like x squared plus y squared and you integrate in that, well, that immediately changes to r squared and you're good. But here you don't. You just have x squared. So what do we do with that x squared? Like how does it change? Well, here we have to go back to the basics. So whether it's polar or whether it's cylindrical, x is r cosine theta. Okay, and so then x squared is going to become r squared cosine squared theta. Okay, so that means that this thing, that extra r, will be multiplied by r squared cosine squared theta. Now, we do want to square, so we're going to have that extra r squared, right? So that's going to be actually r to the third, and then it's going to be cosine squared theta. Okay, so let's just try that and see if that takes it. Okay, so that looks good. All right, so now let's go ahead and integrate. So the first thing we have to do is integrate the inside. Because this integral cannot be split yet because the limit, one of the limits has variables, so we cannot split it. And we should combine r times r squared into r cubed. And so we're going to have dz, dr, d theta. So first we're going to integrate with respect to z. Now, with respect to z, both of these terms is just a number. So we just keep that, right? So integrating the number is like number z. So let's go ahead and do that. So we're going to get r cubed cosine squared z. And then we draw the vertical slash and we're going to say, okay, from z equals 0 to z equals 7 minus r, and we still have dr d theta left, right? Okay, so let's substitute. First, we are plugging in for z, we are plugging in 7 minus r. So that's going to give us r cubed cosine squared theta, and then 7 minus r dr d theta. Now, at this point, this integral is splittable because it's a product of something that just has r times something that just has theta. And the limits also are not variables anymore. So we do have 0 to 2 pi cosine squared theta d theta. and then we have 0 to 4. Now I'm going to go ahead and distribute that r cubed to the each term. So that's going to be 7r cubed minus r to the 4th. Okay, so the r integral is not that hard, but the theta integral requires additional work. So this is where you have to know, and I usually, if I do ask something like that, I will go ahead and include those formulas as part of the formula sheet, because I don't know how many of you actually remember, but these are called either half angle formulas, you can call them, or they come out of double angle, but anyway, whatever. So this is cosine squared can be written as 1/2 then 1 plus cosine 2 theta. So this actually comes out from when you guys were working on calculus 2, they were talking about integrating trigonometric functions. And as part of it, it's only when it's like an even power of sine or cosine, you would need something like that. So what you do is instead of integrating that cosine squared, you use the half angle formula and turn it into 1 plus cosine 2 theta. And 1/2 I'm just taking out of the integral. So let's deal with that one first. So integral of 1 is theta, because you're integrating with respect to theta. Now, what about integral of cosine? So everybody should know that that's just sine. And the argument stays. And if you were to differentiate cosine, it'll be like the 2 will come in the front. But if you're integrating, it'll be 1/2. So not that it matters, because actually once you start substituting, you're going to get 0 either way. So when you substitute 2 pi for theta, this will become 1/2 times 2 pi. And everything else is actually going to be 0, because when you plug 2 pi for theta, this is sine of 4 pi, but sine of any multiple of pi is just 0. And then 0 when you plug for theta is 0, and sine of 0 is 0. So this is just going to be pi. So that part, this whole part, is just going to be pi. Okay, so then what's left is just integrating the r part. So that should be pretty simple. So this is going to be 7 times 1/4 r to the 4th minus 1/5 r to the 5. Okay, and then we substitute the limits from 0 to, I think it was 4 for r. Okay, so let's just go ahead and see if we can use a calculator here. So we got 7/4, and then multiply that by 4 to the 4th power minus 1/5, 4 to the 5th power. Okay, so it's going to be some ugly fraction, but that's okay. So we got 12/16 over 5 pi is what I got here. So let's see if that's correct. All right.